All right, here we go. So we're going to be describing the domain of the functions or relations below. And yeah, here we go. So describe the domain of f of xy, and we've got our function here, or possibly our relation. Um, Now our domain restrictions are going to be when the denominator is equal to 0, or if we have imaginary numbers. And so we've got both types here in this problem. Now, trying not to get too confused, I realize it might be confusing at first, but our domains, seen as x and y, are both some of the variables that we're writing the functions with. We're going to have domains that have x is so-and-so and y is so-and-so. So typically we do talk about domain as just our x and our range being y, but realize that since x and y are both inputs into these, that we'll need to be specific with domains in terms of x and y. And so hopefully that's not too confusing, though I do realize how it might be a little bit tricky at first. So what we're going to do here on the first one is we're just going to make sure that this denominator does not equal 0. And if it does, then it's not part of our domain. It's undefined at that point. So we've got, again, not equal to 0, x squared minus xy minus 2x squared. And that factors out to x plus y times x minus 2y. Again, not equal to 0. We set each of our factors not equal to 0, so x plus y doesn't equal 0, and x minus 2y doesn't equal 0. So on the first one here, we're going to subtract y from each side. Here we'll add 2y to each side and end up with our two domains of x is not equal to negative y. Domain is equal to x is not equal to negative y, and x doesn't equal 2y. Okay, so just again defining our domain in terms of what would give us a 0 in the denominator. If x was equal to negative y, we would have 0 in the denominator. And if x was equal to 2y, we would have 0 in the denominator. So we need to exclude those as parts of the domain. All right, the one right below it, I think that'll be easier to do than the next one. So we'll skip problem, I guess there's not even numbers on, but we'll skip that second one and jump down to this next part, and that will help us once we get back to up here. So again, needing to make sure that the denominator does not equal 0, and that we don't end up with any imaginary numbers. And if we graph this, just this denominator here, what that would look like is, just the piece inside the right-hand there, and the x squared minus 4. I want to just for a second have you kind of mentally graph that. So it's a parabola that's been dropped down 4. Okay, and we can't end up with any of the values, any of the outputs right here, because those would be negative numbers that are inside of a radical. So those would be our imaginary numbers, and we can't have that. Our roots also are going to be excluded, because if they are, if we end up with 0 here in the radical, then it's really 0 in the denominator. And typically you could have the square root of 0, but the fact that it's in the denominator means that we need to make sure we exclude 0. Now that's going to end up not really being an issue, but we'll take a look at that as we go along. So what are the values that would give us these negative numbers? Well, let's factor it out. And so that x squared minus 4, that has to be greater than 0. X squared minus 4 has to be greater than 0. And now we've excluded the imaginary numbers, and we've excluded 0 in our denominator by not having or equal to here at the bottom. So we'll factor out to x plus 2 times x minus 2. And remember, this is going to be greater than 0. And where do we have positive outputs? Well, when x is less than negative 2, and when x is, or when x is Maybe I should even write in the or there. Or x is greater than 2. Okay, and notice there's no or equal to here because those roots aren't able to be part. They'll give us 0 in the denominator, and we can't have that. So we've defined x, but notice that y, even though y is not the denominator, we need to define y because that's one of the inputs for us. So our domain is x is less than -2, or x is greater than 2, and then y can be equal to all real numbers because y is only in the numerator, and whatever it is doesn't really affect our problem. Now, that's that one. Now I want to use this same idea right here on D. And notice here that our roots, and yeah, I guess I should have written those numbers in, but this boundary line happens at x is equal to -2 and x is equal to +2. Now, as we go through this one here, we're going to have the same type of situation. This time, since it's not in a denominator, we can end up with 0 here inside of our radical. That's not a problem, but it still can't be a negative number because that would give us our imaginary numbers. And let's see. Let's go ahead and actually pause, and we'll come back to this in the next video.